find all the real fourth roots of 625 over 2401. So I want to find the real, fourth roots of, and then it's 625 all over 2,401 here. Okay, so I'm trying to find this value here. I'm trying to find the fourth roots of this guy here. So basically what I'm going to have to do is I can either think of this as this entire fraction to the power of 1/4. So that simplifies to 605 to the 1/4 over 2401 to the 1/4. Or you can say it's the fourth root of 625 divided by the fourth root of 2401. So these are all kind of notations that you should be familiar with in terms of the fraction with exponent changed to a square root or some type of fourth nth root, you can say. So what we have here is some type of fourth root, right? So in this case, what I want to do is I would basically use trial and error in this case. So because we don't really memorize fourth roots, so we can say that this guy here, this first one here, just by inspection, I'm looking at 625. The factors are either 5 or 15, right? Because again, it ends in 5 here, right? So let's try 5 here. So if I have 5 times 5 times 5 times 5, would that equal 625? So let's check. 5 times 5 is 25. Times 5 would be 75. Times another 5 would be indeed 625. So I know that the numerator here is going to equal 5 all over. And then finally, and this here is plus or minus 5, right? Because if I'm taking the square root here, I should get plus or minus 5 here. And then finally, this one here would be 2401. I don't think it's divisible by 3 here, because if I'm adding the digits here, 2 plus 4 is 6, plus 0 is 6, plus 1 here is 7, so it's not divisible by 3. So let me try. 1 doesn't work, 2 doesn't work because it's an even number, 3 doesn't work, 4 doesn't work because it's not an even number, 5 doesn't work because it ends in 1. I'm going to try 6 here. So 6 times 6 times 6 times 6 would give me 1296, so that's not correct. And then I'm going to try 7. No, 7 times 7 times 7 times 7 would give me 2401 here. And that's the number I want. So therefore, this would also be plus or minus 7 here. So this solution here is, this is going to be our solution here. And we want the real roots, right? So I can actually ignore all the complex roots that, that have to deal with these guys here. So I can ignore, let me do this in red here, because these are just my real roots, right? I also have technically, if we were to include the complex roots in this problem here, we also have plus or minus 5 over 7 times I here, and we don't really need to know the complex root here, because it's asking just for the real, right? Just for the real fourth roots. So therefore, this is neglected because complex. Because it's complex. So I'll just say it's because complex here. So basically we're just looking at this guy here, and then all we have to do is sorry, this here is just plus or minus 5, 7, right? So therefore my real roots of this problem here is simply just 5 over 7 and negative 5 over 7 here. So these two are the real fourth roots of this problem here, and as you can see, this here is the correct solution. So they basically did the same thing as I did when they did trial and error, because we don't really memorize fourth roots as a mathematician or as any human being, to be honest. So what we're doing here is this 625 here divided by, this should be 1 divided by 4 is going to equal plus or minus 5 over 7. This here is correct. So the solution here is correct. I like how they negated the complex root as well. Solution is correct. Good analysis.